In this video, we're going to take a closer look at the basics of SubD modeling. If you haven't watched the first video in this series, I recommend that you do so. This would be the introduction to geometry types in Rhino. In that video, we talk about the three different types of geometries that you can use for modeling: NURB surfaces, meshes, and SubDs. And this video is going to take a closer look at the third type, subdivision surfaces. All right, so let's start with a few commands, and this list will grow as we go through the video. The first command to get a subdivision surface is 3D face. And when we run the 3D face command, we need to make sure that the output is SubD. By default, it might be set to mesh, but you want to click it to SubD, and after doing that, you can draw either a three-sided or a four-sided, hit enter, or perhaps even a multi-sided polygon as a SubD surface. Now you can see that this one got a little bit corrupted, and we'll talk about that in a minute. But these surfaces are fine. And what we have here is a three-sided SubD and here a four-sided SubD. We can tell the geometry type, of course, if we have the properties window open, and we can see here that we have open SubDs. The next important hotkey to know is tab. Tab allows us to toggle between the faceted and smoothed version of the model. The next thing hotkey that we'll want to look at is F10, and F10 turns on the points for these SubD faces, and I can move those around. But also, I can always use Shift Control, and one of the reasons why SubD modeling is so great is because if I hold down on Shift and Control, at least on a Windows machine, I can grab edges and move those around. Make sure I'm moving that up. I can grab faces. So Shift Control. This only has one face, so it's selecting the whole object. Or I can grab individual points and move those points around. So this Shift Control sub-object selection is really, really useful. One of the reasons why subdivision surface modeling is so helpful is because of its push and pull workflow. Let's look a little bit at that. Here we have this face. If we want to extrude it, the easiest way would be to grab with the gumball, and again, you can turn the gumball on down here, toggle it on and off. With the gumball, you'll see that in addition to the movement arrows of the widgets, the translation arrows, we also have this dot, which is telling us that if we select in the middle of the widget, that we could extrude something. So let me undo that and show how that works. Again, if I just grab the top of the arrow, I'm moving this thing up and down. If I grab the middle of the arrow where this dot is and pull up, now I've extruded this object. So I have just pulled that face and extruded it up. So this push and pull, on the one hand, refers to the fact that now I can Shift Control, select an individual face, and push and pull that around, but I could also extrude that face. Now, while we're looking at the gumball, let's look at the gumball settings. So by default, the gumball, if I align this with the world axis, the gumball is going to be aligned with the X, Y, and Z axis of the model. I can, if I select a face, you'll see that it's still aligned with the X-axis of the model. So if I start extruding out, it's going to pull it that way. But there is another option. If I right-click the gumball here, I can set this to align to the object. And that's very useful because when I select these sub-objects, such as this face, now you can see that the gumball is perpendicular, or sometimes we refer to this as normal, to the face. And if I extrude this out, now it's extruding perpendicular to the face. So if I wanted to start with a simple shape and pull all of these faces out and extrude them, all I would need to do is set the gumball to be aligned to the object, and now it's going to align it to whatever I select. And that's also true for edges and other things, which can be really, really useful. Okay, so we've seen already now that we can use Shift Control to grab sub-objects. We can grab something like this face and pull it down. We can grab individual points and move those around. Now you'll see that there are moments where if I have a quad and I start pulling things down, it's not necessarily going to it's going to behave in this faceted way, but it's not showing me the facet. And so we can talk about strategies for fixing that in a little bit. But at this point, I just want to show you that you can very easily, oops, I think I hit the tab. Okay, so you can very easily push and pull these faces and vertices around, and also then extrude using the gumball as well. And this makes a very easy additive modeling process. Very, very simple. Okay. Now I'll go again. There are two ways to use SubD models. One is to think about the end result of your model being faceted, and another way is to think about the end result of your SubD model being smoothed. And you can look at the smoothed option by hitting the tab key. And this workflow makes it much easier to design surfaces and volumes that would be hard to do with typical NURBS modeling tools in Rhino. But there are some tricks to getting a good outcome from your if you're going to a curved model, and we'll talk about that in a second. I guess I also want to, at this point, let me just I'll hide that. And let's talk about one other way of extruding. So 3D face is the command. So again, the first one in the list here, 3D face, is the command for creating a SubD. And then, oops, let me finish that command. Enter, enter, okay, we have it. And I have the SubD, and I can start extruding it up like that. You'll see that it leaves the bottom open. There's another way that I could do this, and I can also extrude SubD. So I can run the extrude command. It also leaves an opening at the base. Now that's easy to fix. I can use the append to SubD command, AppendFace, and select this subdivision, enter. And now if I enable the object snaps and make sure that the vertex object snap is active, now with the AppendFace, I've got this appended, and now it is a complete volume. So that's one way I could do it. I could use the AppendFace, and let's add that to our list of commands here. So AppendFace is really useful. Okay, what's another way that I might, let me just now do a new 3D face at the base here. You can see if I don't use AppendFace and then draw a new 3D face at the base, that's going to be an independent object. So I could also do it this way. I could just use the normal join command that you would use with a poly surface, and now this is one thing, and if all of the vertices were aligned, then this is becoming a watertight volume, so that's nice. So I just undid that. Oops, let me get that surface back, delete that one. Another way that we could begin to do this is I'm going to offset the SubD. So just like you might offset a surface, you can offset the SubD. You can set this to solid and set a distance. In this case, it doesn't really matter. Hit enter. Oops. Sorry, let me do that again. So it's OffsetSubD, solid should be set to yes. Flip the direction. I've got a distance in there, and now I've got my solid SubD. And once I have that, I can use Shift Control and just pull this object up, right? So now I didn't have to do that step of capping it by appending a face or drawing a new face and then merging it. So there's that. Okay, so this is an interesting thing that's happened here. It's jumping ahead a little bit, that we have this crease here. And I'm not ready to talk about that, so I am going to talk about that in a moment. But let's just make sure that we record this command for our list here. It's OffsetSubD. OffsetSubD is a way that we can begin to thicken our SubDs from the get-go. All right, now let's look at SubD, good SubD topology. Now these are all SubD surfaces, and I know that they're SubD surfaces because when I select them and I look at the bottom right here, I see Open SubD. And if I hit Tab, I can see that all of these things curve. Now, if you are doing, show this model, like that, if your final massing or the final goal is, or the final geometry should be faceted geometry, then you don't have to worry about what I'm about to tell you as much. But when you're designing with SubD geometry and intending for the geometry to be closed, to be curved, to produce double curvature, then the best topology, that is the best configuration for the faces of your geometry, is to have as many quads as possible. So quad in this case is a four-sided shape versus triangles that we have here. And why is that the case? Because let's say I have started with these planes, and I could make a SubD plane in the SubD tools and come to the Create SubD Plane command here, excuse me, and pull out a SubD plane. And I can set the divisions when I'm running the command. I can always add them more later. But so that's how you can make a SubD plane. Now, by default, it's going to give you quads, and this works very nicely because if you start pulling these vertex points, and let me go back to my gumball down here and set that to C-plane, and I can use Shift Control and select this vertex point, pull it up. Shift Control, select this vertex point and pull it down. Now I'm hitting the Tab command, and you can see that I get this nice, these nice transitions when I hit Tab to smooth the geometry. So these very smooth transitions. And you can just tell that everything is flowing very nicely when we hit the Tab key. Now let's contrast that to a triangular configuration here, also SubD, and I'm going to collect this point and pull that up, and click this point, and pull that down, right? Let's get this in maybe roughly the same configuration here, and hit Tab. And now you can see the difference. Like, it's subtle, but this one is pinching a little bit at the top. You can see that the flow of the geometry is just not that nice. You get this kind of pulling. You see it down here as well in this object, where when we go to smoothed, we get this kind of weird pulling at those points. So triangles, or places where multiple points move together or merge together, makes for a less desirable flow for the curvature. And if we convert this to a NURB surface, let's see if there's an implication for that. You can see that we get one kind of thing if we run the same for this one, this surface. So I converted it to a NURB surface. And you can see that the flow here is has produced a NURB surface that I should not be able to explode. So if I go back to standard and try to explode it, this produces a single surface. Contrast that with this, and let me turn the ISO curves off. I've got all of these different surfaces which are now pieced together. So this is not what we would want if we are looking for curved geometry, simply because we would probably go to NURBS at some point and we wouldn't want all of these surface patches. It would be much cleaner to have as few surfaces as possible. So you want your geometry workflow to look like that. And so this is just to say that, like, try to maintain your geometry in the configuration of all quads as much as possible if your destination for the geometry is going to be smooth, a smooth surface model. All right, now let's, now there are, of course, I'm just kind of undo here, and there are, of course, some exceptions to every rule, and one of the exceptions will be this type of configuration, which is known as a Y-joint. And this is the type of joint that you, the type of model that you might be, that might push you towards subdivision surface modeling to begin with, because it's something that would be really, really difficult to model with NURBS. It's a complicated operation to do a joint like this. So what is a Y-joint? Let's just pull this out. I'm going to just copy this geometry over here by holding down on Alt and using the widget. Now I'm going to pull it up like that. Oops, didn't mean to do that. I'll pull it down a little bit like that. So I just shift selected all those faces, moved it down. Now you can see that this is open and I want to close it. I'm going to use the AppendFace command here. Select this, hit enter, and then just very quickly close this in. We'll do it again. And I didn't want to use the offset command. Oops, let's append. So I'm going to select this, this, and this, and append. And you know what? I probably don't have to redo the command every time. So I can do that, hit enter, and it's still live. So I'm going to do another face here like this, enter, and now I'm done. And now let's hit tab, and everything, you're going to know if your model is closed up and nice in many cases because you won't get any dark edges, and it will smooth very nicely all around. So a Y-joint might be something like this, where let's go ahead and delete these faces so it doesn't get so lumpy everywhere. And let's hit tab, and now you can get something like this, right? Now we get a little bit of pulling, but it's internal to the part, so it's not so bad. There might be other ways to model this joint where you could avoid a triangle in the middle, but I think that this is mostly pretty good, and it's going to produce, if we go to the SubD tools and convert, where is it? Convert to object to NURBS, enter. You're going to see that we get a not so chaotic layout of surface geometry here. I'll turn off the ISO surfaces. This is pretty clean. We get, you know, this kind of weird surface in the middle, but still, for the most part, it's a very clean surface. But do note that here, where we have that object or that triangle, we get slightly dirtier topology, even when we go to the surfaces. Now, one of the reasons why, so let's talk about curved. In the last video, the first video, I looked at some of the commands for doing faceted modeling. And in this video, let's look at some of the things that we might want to do to make more elegant curved models. So you'll notice that by, let me just undo some things here. By hitting the tab key, oops, went back too far. Let's enclose this surface. By hitting the tab key and filling in these end caps, you can see that curves everything here. But the geometry behaves very differently, and then to get rid of that face, I'm just Shift-Control selecting it and hitting the Delete key, so that's handy. You can see here that this is giving us a much sharper edge around that, around the end of this tube versus the other ends, which are capped. So having open geometry, an open edge will tend to introduce a crease to geometry. Understanding how to insert surfaces, extra edges, to control the way that geometry smooths is the key to subdivision surface modeling in Rhino or other programs. So what do I mean by that? Well, what I mean is that when we hit and let me just change the proportion of this so these this object is more square. Okay, so when I hit the Tab key, I get a circle happening here, right? Which means that we're getting a very smooth edge. And maybe actually it would be easier just to show this with a simpler edge here. So let me just grab that. Thought that might work, but it didn't. Shift-Control. I'm just going to delete most of this object. Shift-Control, select all this stuff, delete. Shift-Control, delete. Okay, so now we just have one edge on this OpenSubD, and I'm going to copy this. Oops. Make a couple of copies of this, holding out down on the Alt key and just moving the gumball. All right, so by default, when we hit Tab, oops, we have this little pinch here, which we don't want. So how do I get rid of that? I think that this might be a moment where I'm just going to, up here, there's a way to crease, and I can remove creases. So let's just make sure there are no creases on this thing. Now everything is smoothing out when I hit the Tab key. Okay, so we get this smoothing here, and you can see that there's a very rounded transition when I hit the Tab key. Now, if I want there to be a sharper transition here, I can do a couple of things. One is I could add a crease, but then if I add a crease along this edge, so let me just Shift-Control that and add crease. So now you can see that hopefully you can see on your screen that we have a light line here and then a darker line here, which is telling us that this edge is creased. And now if I hit the Tab key, you can see that this goes smooth, and now I have a very sharp edge here, right? So that is going to be called the crease command. So just call it crease. That's a good one to know. So let's just add that to our list of commands here. So we'll call that crease. And then to get rid of it, there is going to be a remove crease, which is just that phrase, remove crease. So we can see that here we can add a crease. Here there is no crease, and if we want to get rid of that crease here, we can come back up to this command or type remove crease and get rid of it, or add it back. So let's keep that crease, because let's look at other ways that we could begin to control the radius at this in this geometry. One really easy way is to add an edge loop. There might not be a loop of edges, but we just want to insert an additional edge. And so if I Shift-Control this edge, I can left click, and this is going to be this command here, InsertSubD edge loop. And you can see here that there's some options. By default, it's going to be on one side only. But even already, you're going to see that that's controlling, compared to this one, how much the curvature is happening, right? So let me undo that, because I can also, the command now is InsertEdge. I can put it to both sides. and get this very even offset on both sides. And now when I hit tab, I get a really nice transition here. Now let's go back one step, because I want to cover one last thing about the InsertEdge command. Now the last option. Let's make these two faces very different in proportion. So I'm going to again InsertEdge, both sides yes, and then I'm going to make the offset. By default, the offset mode might be set to proportional. And now you can see that as I slide, it's using the same percentage. So maybe this is like 25% on one side and 25% on the other. Let me just click enter to commit that. Now you can see that the offset on this side is much shorter, the offset on this side is much greater, because we have it set to proportional, and proportional means in proportion to the face that it's on. And so we may not want that. Let's say we want more of an even distance on both sides. InsertEdge, let's change this to absolute. And now we're getting the exact same distance on both sides. And I think that in many cases that's going to lead to a cleaner transition. So now you can see that we have these two transitions. These three transitions. We have this like very deep transition. We have a sharp transition because we're using a crease. And then with this one, we're inserting edges, right, and controlling that, so we get a curve that's more like just a rounded edge there, right? And as we, oops, let's go back. Let me undo that. Let's say that if I move these further away from that edge, then we go back to this more gentle transition. And if I were then to go back to tab, move these edges really close to that edge, then we're getting closer to a crease then. So we get a little bit of rounding, but it's really, really now much tighter. So the closer, so we go back to tab, the closer these edges are to the edge, the tighter the turn is going to be. And then the last thing that we could do is we could select this edge. And so that, let me just make sure that we're keeping a good list of our commands here. That's InsertEdge. It's a super useful one. And the InsertEdge is going to control the way that we turn the corner. Another way we could control turning the corner is with Bevel. And you can see here that we can, just like the edge loop, we can slide the bevel to change the radius. So this is really nice. And along with that, we can change the number of segments. So by default, maybe 2 is a good number, or you could go to 3. You could go to, you could make this much higher. But let's say 3 is nice, and then we can kind of control this and hit, oops, let's try it again. There we go. And I committed that, and so now we have that. So it looks a lot more like the transition that we're going to get once we hit tab and smooth the SubD out. All right, so we have 3 different ways of, or 4 different ways of turning the corner. We just have one poly edge here, and that gives us the most gradual radius. We have the crease, which gives us a really sharp turn, or like a 90-degree bend in this case. We can use these offset edges using InsertEdge and tighten the way, create basically a weight around that edge. And we can vary the distance of these things to control the transition, or we can use the Bevel command to insert that. Okay, well, what is that going to look like on a real application? So let's try this. So let's see how we might apply that to this. Okay, so maybe this is fine, but maybe we actually want a much tighter turn. for our tubes here. So let's just select this edge and see what happens if we type InsertEdge. Will we get an okay result? We may not. So this is where the triangle here is not helping us out. Now, can we fix that? Yeah, we can. I'm going to AppendFace and select that. I'll put this guy in like that. Enter. And then rebuild the geometry here. Hit enter. Okay, so now we have good continuity for our edge flow here. And now if we hit tab, aha, you can see that we get a much tighter turn here. So let's keep going with that idea. And if we insert, now I did this and I inserted the edge and I didn't give it a distance. So let's see what my units are here and what the distance is here. It should be in inches, and so this is 16.62 inches. Let's see what I might want my offset to be, something like 1 inch there. Okay, so what I'm going to do now is I'm going to select a bunch. Okay, can't select a loop there. Select all of these edges, right? And let's see what happens if we do this offset, absolute 1 inch all over. So I'm selecting all of these edges, boom, boom. And now, let's see what happens if we do it here too. We can select them all. Okay, I think I have all of my edges selected. Insert edge. The mode is going to be both sides, yes. The offset mode is absolute. I'm going to say 1. Enter. And it's given me some wonky results here. Let's see how it smooths out. Looking pretty okay, actually, when we go to the smoothed out mode. But you can see it's a much tighter transition. And tab. Some of the geometry, though, when we go to the facets, what's happened here is that some of the vertices here are not exactly where we want them to be. So how would we fix that? We could just pick those points, I think. The ones that are in strange places. And once I have them all selected, maybe, where's my gumball? C-plane, object, center that on the object, shift, select, maybe I can pull those in. So I just scaled those in a little bit, and that seemed to fix it. But actually it made things a little bit worse in terms of the final smoothing. So so that's not the best, that did not give us the best results there. And I think part of that is because we have this quad, or this triangle here. Now let's look at maybe a better scenario where we don't have that triangle. Let's look at a different, before we do that, let's just see what the bevel would do to that command, to that edge. So let's try the bevel. Okay, so you can see here that bevel's giving us a much better result there. So let's go ahead and wonder what would happen if I inserted the edge like without insert edge. Yeah, it's not giving us a great result. So let's see what happens now. Let's just select all of the edges here. All of the edges. Then we might want to bevel. Maybe we want to also bevel these. Okay, and let's type bevel. Whoa, that's just giving us what we had before. Let me turn off the edge loop here, or the object snap. it's snapping to something. Let's just hit 1 because it's in absolute mode. Absolute mode. I didn't select all of these interior corners, but I did select one, so you can see the kind of difference here where I did one. The problem with Bevel is it gives us these kind of complicated intersections here, but this is super clean right here. And you can see that actually that works really, really nicely down there. And I forgot one down there. So let's just redo the Bevel command here. Go back to tab. And there we go. Let's select everything that would be good for a bevel. So just these top edges up here and just these bottom edges down here. And then let's bevel. And I'm going to use 1 inch. Enter. Okay. And now let's hit tab. And now you can see that I've changed the way that this object smooths, and it's really clean, and we get this nice this nice box-like shape. So we have rounded corners on this thing instead of just a rounded tube like we had before. So that's really nice, and it'll show you how you can use the edge flow in. So that was Bevel. But InsertEdge is useful, and I'll show you an example, a better example. That's the trickier example because we have this triangle in the middle, and that makes things tricky for our topology. All right, well, let's look back now at a kind of canopy configuration. How might we make like a simple canopy here? Okay, well, maybe we would do something like this, where we would start with a plane, and how would I begin to turn that into something 3D? Let me just delete that. I'm just going to Shift Control, and I'm going to pull this up. Okay. And now when I hit tab, I have this this shape, and maybe I want this to be the beginnings of some sort of canopy. Maybe I can make this a little bit more interesting by, oops. Well, let's see here. No, let's just keep it simple for now. All right, so we could just extrude this whole thing. Oops, trying to extrude it down. So I pulled that down and it made the edges. Maybe the better thing to do here is to extrude it up like that. But that gives us a hollow, or it doesn't close the form. So if we want to start thickening this so that it can be, number one, we know that when we hit tab, we get this nice smooth canopy, right? And what we want to do here is to give it thickness. I am going to go back and look at our commands here. There's the OffsetSubD command. So I'm going to use that offset command here. And the offset is going to give us a good result. Oops. And it needs to be OffsetSubD. So I'm going to offset this. I'm going to flip the direction. So it's going down. The distance, let's make it, I don't know, like 5. Both sides no, solid yes, delete input no. And okay, so now we have this canopy going extruded down. Now our original SubD is still there because we selected no when we said delete original selection. And so now this is our canopy, and you can see that when we hit tab, it's now thickened. Now, what's the nice thing about this? The nice thing is that we did this offset, but now we could have a variable thickness here. So we could say, like, here we want this part of that canopy to be thicker, and then we want it to be thinner as it goes down. Let's just hide that. Zoom selection, and now we can hit tab. right? And you can see that this thing is thinner over here and thicker over here. So this, and we can just use this kind of push-pull modeling to very easily think about different options for what this thing wants to be. Along with that, let's say we want to extrude some part of it, right? Like we can now just keep extruding here, and let's hold down on Shift, and now we have like this column here holding something up, and when we hit Tab, we get this kind of surface. We could take that face and Tab. We could begin to, I'm trying to get that face, delete it, Tab, and then we have this column, holding up something here. So that's pretty cool, and you can continue to think about, okay, well, how would I put a hole in this thing? Well, maybe I could delete this face and this face, and then I could use the AppendFace and begin to AppendFace, and then I could begin to fill in these edges here. Do the last one. Oops. If I got it, enter. Okay, and let's see if this all worked. All right, now there are some mistakes here where we didn't fully append. So let's go ahead and run the append command again. Select this. And now I want to make sure I'm on that point, on that point, on that point, on that point. Enter and enter. And let's run it again. 1, 2, 3, and 4. Okay. It looks like this one is not right. Oh, well, that one's just not joined. So let's just join these things and hit enter. Okay, now I think we should be, okay, so now we get a hole in this thing. This would have been kind of difficult to model as a NURB surface. So if we want then there to be more of a sharp transition around that hole, what we can do is select all of these edges here around the top. And then we can use the InsertEdge command. Okay, now something is wrong with our topology here, because it should be recognizing that we are, I'm going to go to, so fixing things is a good way to learn. Let's go to the View, Display Options, and let's make sure that we don't have, let's see, rendering for our backface settings. Let's use a single color for all backface settings. I had this set to red. Okay. So, this is very curious because everything looks right here. So I'm not sure why. Now it is not recognizing this as an edge loop for some reason. Let's use another technique for filling this hole, which is going to solve our problem. And we'll add another command to our list here, and I didn't know when I was going to introduce it, and here's a good place to introduce it. This is called bridge. All right, so bridge, first set of edges or faces to bridge. So I am going to shift select this edge, enter, shift select these edges in order. That's the first set. And then I'm going to select the second set in the same order and hit enter. And now you can see that it's zapping everything together in the same, and it's filled all of those things at once. And it looks like a nice clean geometry here. Now if I let's see if I can insert an edge here. Trying to grab all of those. Insert edge. Still not. Oh, I don't. Let's turn both sides off. Absolute, let's change it to proportional for this and go on this side. And I think this is now working. Okay, that worked really, really nicely. And maybe it was working before and I just missed it, but now I could show you the bridge tool. Let's insert another edge here and bring that up. And now when we hit the tab key, you can see that we're retaining the thickness around that edge instead of it going to this razor thin edge. Okay, let's see here if we can get an edge loop. Yes, okay. Now, if your geometry, in certain cases your geometry, and in certain places your geometry will get these loops of edges, and when you hit Shift Control, you can double click on the edges and it's going to select that loop. And that is when you have an edge loop like this, you can have, well, the loop isn't always a loop. Sometimes it's just like a bunch of edges in a row. So if I have a plane here and I double Shift Control, hold down Shift Control, double click, and I'm selecting all of those edges, which that can be really useful. Or in this direction, I can Shift Control and select all of those edges. So double click, I'm sorry, I'm double clicking. Shift Control and then double click. And then if there's a ring of edges, you can Shift Control and double click, and that can be really useful. So let's say I like where this is headed, and yet I don't like this crease on the outer edge. Well, I can get rid of the crease here and get rid of the crease here by Shift Control, double clicking those edges, and then hitting Remove Crease. Okay. Now it looks too much like a mushroom. So I want to insert some edge loops here. It seems like I've somehow lost the understanding of this is an edge ring, but that's okay. I can Shift Control, double click all of those edges individually, and now I'm going to come back to InsertSubD Edge Loop, left click here, proportional both sides. It's not liking this. I don't know why it's doing that. That's weird. I'm not liking what's happening there. Now I must confess that I'm more comfortable SubD modeling in Maya because that is the platform where SubD modeling was available for a long time before Rhino and other software packages as well. So I'm still getting used to the quirks of Rhino's SubD, but let's try to. So I'm going to not do both sides here. I'm just going to do one side for the offset, and I'm going to come in on this side, and that works nicely. So now when I hit tab, you can see that I'm still getting this much more rounded curve on the bottom, but now I'm getting a tighter curve up here. So let's now add that tighter curve to the bottom. Okay, this is going to be an interesting moment here because we have, you know what, let's just keep this. We can add that edge loop on top of that, and that's not going to hurt anything. It's actually going to be a good thing. Double click that and double click this one, and I think I have everything I need. No, I'm missing that one. Okay, now I'm going to insert the edge loop again, so I can grab that here, and I'm going to just kind of come up all along that edge like that and click there, and now hit tab. Okay, and so now I'm not getting the sharp crease at the edge. I'm not getting as really as lumpy as it was before, and now I'm getting just a nice transition. Now I could experiment with the bevel as well and other commands, but this is giving me the sort of basic, maybe basic shape that I want. So kind of thickness with a rounded edge here. So this is how you can begin to control things here. Now I can continue modeling with this, this thing. Now one thing, what I would say, so I've added some detail here, but a good strategy for SubD modeling, I would say, is to, let's say maybe you take it to this point and you like this, make a copy of the thing that you're working on before you commit to a lot of changes. Like start adding edge loops and a lot of details. That way, if you don't like the workflow, you can go back to the edge flow. You can go back to the original one. Now, I can see here that there's some things that maybe I don't like about how this is working. Maybe I want this edge pointing. Those two things are lined up, but it's kind of coming to this. There's an interesting transition here, right? Where like this is flatter than that. And so I might want to fix that. And a lot of times we just push and pull vertices. So maybe I'd set up some geometry here, hit F10. I could hit Shift Control. I'm just going to like maybe use this reference geometry and snap that to this, so that I control how that is working. I've got this funny foot here, but let's say we could get rid of that. Go back by coming in and giving ourselves a crease here. So go back to SubD tools and crease that. There's the crease, like that. Tab. Okay. So now we have this crease. Maybe I want it creased on the bottom, but I don't want it creased up here. So tab. Let's add a crease to, actually, it'll probably just get rid of the crease if I bevel this edge. So Shift Control, and let's get rid of those things. And let's just see, let's bevel this edge too, just for kicks. Let's see what happens if we bevel this. And we're going to do something like that. Okay, and now tab. Kind of funky the way that it's beveling out there. So let's not do that. Let's undo that bevel. I think what's going to be better here is to undo that crease, get rid of that crease, and then let's use our insert edge loop here. So let's insert edge, and let's insert an edge right there, and then hit tab, and there we go. Now we get this kind of nice rounded shape at the top, and then we get a sharper crease at the bottom, which of course we could always come back down here, and we could remove that crease, hit tab, and then insert the edge like that, and tab. Okay, there we go. And now we have that flowing very, very nicely. And we could now keep going with this if we wanted, or we could convert it to it's not the most beautiful model I've ever made, I'll confess, but I think this gets the point across. And the nice thing about this is that we could say, okay, well, now we want to add another column here to hold up this other side. And let's go back to the box. Let me show you a little trick here. Let's take the gumball to the world. And if I want to snap these to the ground, make all of those, I'm sorry, all of those things level, select all of these things. If I just start like taking my scale widget, and in the z-axis, if I move those up a couple of times, eventually all of those things are going to snap to flat. And now I could move all of those and constrain it to vertical and tab it to here like that. And now I've got these two columns that are holding this thing up, and I could, you know, scale this thing, or slide it around, do whatever I wanted to do. And so it's very easy to just make geometry on the fly like that. And again, this is still a kind of lumpy looking thing, but it can be much more elegant as you begin to add more edges in. And that's just it takes a bit of experimentation to control how you put those edges in. Maybe another trick for getting all of these things to the construction plane, let's say they're all out of whack here, I can take all of these things and project to C plane, delete input objects. Let's make sure we say yes. And the construction plane was actually up here, so this is all below, but now all of those things are lined up and I could pull them down something. So let's say that this thing was higher than the construction plane, and let's select those, project to C plane, delete input objects, yes in this case, and now it's going to pull all of those things down. And now that's like holding this thing up. Okay. So again, this one's kind of a lumpy mushroom looking like thing. Not the most beautiful model, but I think that this begins to give you a sense of how you could control your objects. And this push and pull method can be used in lots of ways, whether using so let me maybe show you another way that you could think about using this. We could shift. Let's see here. I think if we Alt, selecting all of these edges, and then I am selecting Alt, and let me change the let me pause the video just for a second while I remind myself on how to do this. Okay. So let's say I want to make a window into this, or an opening. What I can do is I can start the extrude and pull it up a little bit, and then shift and scale everything evenly in, right? And I could delete this, and then I've got an opening. I could, if I wanted this to be in the same plane, then I could select everything. I could move, constrain it to vertical, and move this, oops, I want to constrain it to vertical, yes. Move it from here to match those, and now I've got this opening. So you can use the extrude actually to give yourselves things which are flat. Then of course, Shift Control, double click, and I could pull this down. You know, I could do many of these extrusions. So let me show you how that trick works again. Move that up, Shift, scale this in, move, constrain to vertical, move that down, delete that, and now I have this opening here. And I could continue maybe giving that a thickness if I wanted to. Maybe I want this to now, maybe I do want it to come up. I can click that, right? And so this is more of a kind of hard surface, faceted technique. Although, of course, you can like turn that into things which are curved if you want to. But the final trick I'll show you here, maybe to produce a slightly more elegant model at the very end here, is to so this plane is SubD. So I'm going to click these things and pull that out. Oops. Click those three edges. And I'm going to extrude this, and maybe extrude it again. And I'm going to pick these two. I'm going to pull those up, And I'm going to pick those those vertices, and oops, don't want to move them. I want to extrude them, so do that. All right. Okay, so now tab, I'm getting something like that. Let me crease these corners. So I'm going to crease those corners, then I'm going to hit tab. Now I'm getting sharp around the edges. And now I want to insert some edge loops here. So I'm going to select both of those, go back to my friend, well, I'll just type it, InsertEdge. I'm going to do absolute, both sides, yes. And then I kind of come like that. And I've offset on both sides like that. Okay, and now I'm getting this nice kind of transition here. It's not so blobby. And now I'm going to double click these edges, and insert edge, both sides. Yeah, do that, like that, tab. Okay, now you can see how this is transitioning very nicely. And now let's show you another way that we can use InsertEdge. And I'm going to grab that edge, insert, and I'm just going to come here to the middle. And I'm going to select these things and like use that flatten out command so they all go to the same height. And I'm going to move them down to like here, like that. And maybe I want to use that again, and then you do it in like that direction. There we go. So now I'm getting this nice surface transition here. And let's repeat that operation over here. And in fact, let me just maybe show you. Let's insert an edge here. I'm going to mirror this. Let's do a different type of thing where I'm gonna, let me just pull this over to like basically the middle here. And I'm just gonna shift control all of these things like that. Then I'm gonna mirror, so I deleted a bunch of faces. I'm gonna, let's say I just want this to be perfectly symmetrical. I just copied that, and now I'm going to join them. And that is now one thing, and then I can delete that edge, and now I have this perfectly symmetrical thing, right? And maybe this is like something that is becoming a much more elegant canopy, and I can kind of pull that down. Maybe I now move that all up. Didn't like the way that got pulled up. So let's do not a pull up, but an extrusion should be nicer. Like that. Okay. And now let's get rid of that like weird lumpiness here. And let's see if we can select all of these things, and let's try I know what I need to do here. What I really need to do is I need to insert an edge loop. Insert an edge loop that really cuts across this thing. You know, this is where planning a little bit can be helpful. What would be the best way to do this? Let's delete that. Okay, can we, what happens if we insert an edge here? Both sides, no. Okay. So now if we insert an edge here and link it up to that one. Okay. Now I think we're getting somewhere. Let's insert an edge here and do that. And then select this edge again. Insert an edge and do that. Now do we get a nice transition here? Not so bad. So let's just do that on these sides. I'm doing this really quick and rough here, but select all of these things, insert edge It's not giving me much. Cutting me much back slack here. So both sides, yeah, I'm doing that. Shift enter. I'll do this one. Shift enter. I'll do this one. These are not going to be symmetrical because I'm doing this real fast, but click that edge, insert an edge loop. Both sides. No, why is it going to both sides by default? Oh, because I was using both sides. Okay, fine. Select that one. Boom. Select this one. Boom. Select this one. Get that one. Like that. So I'm just, because we don't have a continuous loop here, I have to do it this way. I'm just going to get rid of that edge. Get rid of that edge because I don't need it. No, it's not the most perfect, but I think we could clean it up and make it a little bit better and really investigate what's going on there with the transitions. But we're getting a better overall sort of result here. So I just wanted to show you that you can use this. Now let's go back to the tab key. And now I'm going to extrude this up, right? And then we could fill in the top of this. But I wanted to show you that you can use this in a much more refined way to model things which are not lumpy dumpy, but also things which look quite refined. So I wonder now if we could maybe get a good edge flow here simply by pulling all of these guys. Now let's see if we can, it's going to allow me to insert an edge. Just doesn't like that, does it? Yeah, there's some weird topology thing here where I clearly don't fully understand. Oh, well, let's try doing it from this direction because that one is less tricky. Insert edge. And then I'm going to insert that edge actually way up here. Or, you know, I could just insert it there and then pull it up like that. Oops, tab. There we go. And let me just remove, there might be some creases on this. Where am I? Remove all creases. Maybe that helped a little bit. Or maybe what I simply need to do is I'll get a better result if I could be that these vertices aren't merged, but they look, that's the problem. There's some vertices, see, those vertices are not welded together, and that's why we're getting weird results, because these vertices are not merged together. So we have to use a command called stitch, and stitch is then going to allow us to stitch all of these things together, and probably going in overtime here, but let's go to F10 and stitch. So we want to stitch that point to that point like that. So the way I was doing this operation was not leading to stitch geometry. Tab. Aha. Now that looks a lot cleaner, and that looks good. That looks like what we want to see, where I can just tell that things are like pushed together in a good way. So so the way that this is modeled, I modeled it was a little goofy, and it wasn't stitching the vertices together. But you can always link things together with this command called stitch. Oops, make my SubD here. I'm going to flip this. So here we have two different SubDs, but I could use the stitch command to put that point. I could stitch these edges together. Oops. like that. So that's one way we could do it. Or we could stitch this point to that point like that, and that point. Stitch this point to this point like that. And now we've got that thing stitched. So you could keep going from there. So if we wanted to fix this thing, and I do want to fix it. So I fixed that surface. How would I fix the rest of them? Let me just grab points and pull these things down so we can see where they're not linking up on the inside. It's a bit of a pain. Is it happening multiple places? It's happening multiple places, so I don't want to fix it. So there's probably just a better all-around way for me to do this if I wanted to fix this at this point. And I think that way, now that I understand the geometry flow that I want, would be just to delete all of this and actually to delete all of these things too. And then, that's being understood as an edge loop. And so rather than going through the time-consuming process of trying to stitch everything, I can just delete what's not working. And then if I just extrude that out from that edge, now I can see that everything's lining up. And then if I want a more realistic transition there, all I would need to do is, I would think what I would want to do is grab all of these things. In fact, I'm going to undo, oops, redo. And to just set up the transition, it's going to be faster for me to pull these things now. Then bring this out. And then maybe I keep going the rest of the way. Okay, now I have like a lot of edges here, but all of these edges are leading to a pretty good transition. Not perfect here still. And so maybe I want to come in and try to select all those edges. There's something about the way I've set up the geometry here, which could be nicer. If I could come into this and shift control all those edges. Let's see what's happening now. Let's try to like, I'm just trying to see if I can flatten them out a little bit, but that doesn't seem to be working. It could be that there are still some edges here, and this is where like troubleshooting your geometry can be helpful. I want to do this. Yep, I think that's the fact that we have edges that are not stitched together.
Oh, sorry.
So that lack of stitching here is what's causing the problem here. And how would we fix that? Now in Maya, there's a command called like merge all points within a certain threshold, which is like really, really useful. And so that's probably what we would want to do. What we might do here is, if we didn't want to go through like a big hassle, is see if it's possible to find a moment, like back up to a moment where things are still okay. And see if this extrudes nicely. Maybe. Maybe not. All right, well, to avoid any further confusion, I'm just going to let this one go. But I think that what I hopefully can show you here is that by adding edge loops, you can get things which are surfaces which are much, much more elegant. And then by using stitch, you can just make sure that all of the vertices are tied up and everything is working well. And there's a lot of fun stuff that you can do here. Like if I just, especially with say like the bridge command, things that would be really hard with NURBS modeling. So if I have this, like I just made this SubD sphere here. Let's say I want like a tunnel through this thing. I can select that edge loop, select that edge loop, type bridge, and then bridge options. You can see that I've glued these things together and I have this tunnel through the sphere. And then by inserting edge loops, so if I get this kind of edge loop going here, insert, and I can bring this down in and then tab like that. You can see that I can like really kind of control that tunnel, and then by adding more, do like a clipping plane through there. Right, you can see that I've got this this tunnel moving through here, and that would be like really difficult to do with NURBS geometry. So I am still getting the hang of SubD modeling in Rhino clearly, but hopefully I have introduced the basics, and I think that as you experiment with it on your own projects, you'll come to understand the benefit of this workflow. And of course, at the end of it, when we're happy with something, we can always then convert it to a NURBS object and use all of the polysurface commands that we know with the geometry and keep going. And that makes for a very powerful workflow.